Hello friends, I am Chandan. Today's topic is heat, or you can say that heat transfer. So let's try to understand what is heat transfer. So it is basically energy transfer the by the virtue of temperature difference is known as heat. So what is heat? That is energy transfer by the virtue of temperature difference is known as heat. Now there is a heat. Heat is proportional to the mass m, and heat is proportional to delta T. If the delta T is more, then heat transfer will be more. If the mass is more, then heat transfer will be more. So from this we can say that is Q proportional to m into delta T. M is the mass and delta T is the temperature difference. From here you can say that Q that is equal to mc delta T. C is the proportionality constant. Here C is basically known as specific heat. Okay, so this formula that is very important. Q that is equal to mc, Q that is equal to mc delta T. So from this equation you can calculate what is the heat transfer to any system or from any system. Here C is the specific heat. Now from this equation you can say that C that is equal to Q by m into delta T. Okay, so what is the unit of Q? That is kilojoule. So the unit of Q that is kilojoule, and unit of mass that is kg, and delta T that is um, Kelvin. So the specific heat unit is that is kilojoule per kg Kelvin. Okay, now so what is specific heat? Suppose if m equal to 1 and delta T equal to 1, then C is equal to Q. So this is the specific heat. So what is specific heat? Specific heat is the amount of energy required to change the temperature of unit mass of a substance by unity. So this is the definition of specific heat. Okay, this is the definition of specific heat. Okay, now understand the sign convention of heat. So this is very important sign convention of heat. Okay, suppose consider this is a system. System means where our study is focused. So this is our system, and from this system the heat is rejected from this system. Suppose this is 10 kilojoule. This is 10 kilojoule. So what is the sign convention? Remember this. Here heat supplied to system is positive, heat supplied to the system is always positive, and heat rejected by system is negative. So basically heat is supplied to the system. So basically here heat is rejected from this system, so this will be negative. Okay, this will be negative. So here you can see that heat supplied to the system is negative, or just remember this data, here heat rejected by system, that is positive. So heat rejected by system, that is positive. Heat into the system is negative. Okay, so heat rejected by the system, that is positive. So here heat is rejected, so that is why it is a positive. Okay, now you can say that from here you can also say that heat supplied to system, that is minus 10 kilojoule, heat supplied to surrounding, that is plus 10 kilojoule, or you can say that heat rejected by surrounding, that is minus 10 kilojoule. Okay, now suppose there is another system. So this is another system. Here the heat is into the system, that is 10 kilojoule. So you can see that heat rejected by system, or you can say that heat supplied to the system, sorry, heat supplied, here heat supplied to the system, that is plus 10 kilojoule. So heat is supplied to the system, that is plus 10 kilojoule, or you can say that heat supplied to the surrounding, that is minus 10 kilojoule, because outside this system, so from this outside of the system, outside of this system, so basically there is a surrounding, this is surrounding, so you can say that heat supplied to surrounding, that is minus 10 kilojoule. Okay, or you can say that heat rejection by system, that is minus 10 kilojoule, or heat rejected by surrounding, that is plus 10 kilojoule. Basically, when heat supplied to the system is positive, and heat supplied to the system is positive, and heat rejection by the system, that is negative. So basically you have to remember this data, heat supplied to the system, that is positive, and heat rejected by the system, that is negative. Okay, now let's try to understand the specific heat. Now here, note point that first point is that for liquid there is only one specific heat, because liquid are incompressible. So when there is a liquid, there is no concept of CP, specific heat at constant pressure, or specific heat at constant volume. So basically only there is only specific heat term is coming. So for liquid there is only specific heat is coming to the picture. Now for gases, Cp, Cv both exist, and it will be different. For gases, Cp and Cv both are different, and there is a relation, that is Cp by Cv, that is equal to gamma. Now for monoatomic gases, Cp, Cv, gamma, that is equal to constant with respect to temperature. Okay, so gamma, that is equal to 1.67. Now in case of monoatomic in case of non-monoatomic gases, Cp increases. If Cp increases, Cv increases, then gamma is decreasing. Okay, if Cp is increase and Cv is increase, then gamma will decrease. Now what is the value gamma for monoatomic gas? Example, that is helium, argon, the gamma will be 1.67. For diatomic gas like oxygen, nitrogen, gamma will be 1.4. And for triatomic gases like CO2, SO2, the gamma will be 1.33. Remember this data, very very important. So for monoatomic gas, the gamma will be 1.67. For diatomic gas like oxygen, nitrogen, the gamma will be 1.4. For triatomic gas like CO2, SO2, the gamma will be 1.33. Now let's try to understand for gases what is Cp, specific heat at constant pressure, and what is specific heat at constant volume Cv. Okay, suppose consider it consider a constant volume process, a constant volume. So here this is our system. So here this is our system. System means where our study is focus. So here there is a cylinder, and upon this on this cylinder there is a piston is there, and there is a rigid wall is there. Why this rigid wall is there? Because piston cannot go on upward direction. So basically this is restrict the piston. Okay, this is restrict the piston. Now suppose there is gas is there inside this system, and the mass of the gas, that is 1 kg, and if you try to increase the temperature of 1 degree Celsius, then you must supply heat from this side. So this heat is equal to Cv. So you know the formula. What is the formula? Q, that is equal to mc delta T. If it is a constant volume process, then C will be Cv, specific heat at constant volume. If mass is 1, suppose mass is 1, and delta T is 1. So what is Q? Q is basically Cv. So why? Because if M is 1 and temperature increase, suppose delta T, that is 1 degree Celsius. So here, from here you can say that the heat supplied is equal to Cv. Okay. Now from, if you can suppose consider a constant pressure process. So this is our system here, and here there is a piston, and here this piston can freely go upward or downward direction. Okay, so in this system there is a gas is there, and the mass of the gas is 1 kg. Now if you want to increase the temperature of this gas by 1 degree Celsius, then you must supply the heat from this side. So if this is from this side, if it is Q dash, suppose this is Q dash. So Q dash will be Cp. So we know the formula, that is Q that is equal to mCp delta T. Then if m is 1 and delta T is 1, so Q dash for this is for constant pressure process, suppose Q is will be Q dash. Now from here you can say that Q dash that is equal to Cp, specific heat at constant pressure. So from here this is written in this here, Q dash that is equal to Cp. So here in that system you see that the system here, this is the system here, the temperature of the system is increases and the piston goes upward direction. Why it is upward direction? Because the heat is supplied to the system. Due to this heat supplied, the area, the volume is increases because pressure is increases. So that is why the piston goes upward direction. So we see that the piston easily moves from downward upward direction, easily move to upward direction. So here uh, here basically uh, in first system, in this system here left side, that is control volume process, there is only internal energy increases. But in right side, in constant pressure process, the internal energy of the system is also increase, and the piston is goes upward direction. That means there is some boundary work is there. So that is why the value of Q dash is greater than Q. So that is why Cp is greater than Cv. Now Cp for air, that is equal to 1.005 kilojoule per kg Kelvin, and Cv for air, that is equal to 0.718 kilojoule per kg Kelvin. So remember this data. This is important for air. This is important, very very important. Okay. Now here what is written in this here, the hence specific heat at constant pressure is more than specific heat at constant volume, because Cp include both boundary work as well as internal energy, but Cv include both internal energy. So basically in constant volume process only internal energy increases, but in constant pressure process there is internal energy increases and boundary work is also there, because piston goes upward direction. So that is why there is some boundary work is there. Okay. So this is all about specific heat at constant pressure and specific heat at constant volume. Now there is one math. Just read the math and understand it. Here the math is that a person starts a 60 watt table fan in an insulated room of volume 86.4 meter cube. The person expect to cool the room from 32 degree here 32 degrees Celsius, and pressure is 100 kilopascal, and allow the fan to rotate for 4 hours. After 4 hours, the person will find that the room is here CV, that is value is given, that is 0.718 kilojoule per kg Kelvin, and R value, that is 0.287 kilojoule per kg Kelvin. R is also given. So basically the person find out the temperature difference. So basically here you have to find out the temperature difference, T2 minus T1. So what is the value of T2 minus T1? So from this value we can comment on that the room is hotter or cooler. So basically you have to try to find out that is T2 minus T1 value. So first of all, what is given in the question? So here a person starts 60 watt table fan. So here there is 60 watt table fan is there. Is an insulated room of volume, that is 84.6 meter cube. The person expect to cool the room from 32 degrees Celsius. So initial temperature of this room, that is T1 value, that is 32 degrees Celsius, and pressure, that is 100 kilopascal, and allow the room to allow the fan to rotate 4 hours. So the fan is rotating for 4 hours. Okay, and after 4 hours you have to find out the value T2 minus T1 after 4 hours. Okay, that means temperature change, and CV value is given and R value is given. So here this is insulated. In this question the insulated term is coming to the picture. So this is insulated. So this is our system here. This is insulated. Insulated means there is no heat transfer, and the fan is rotating. This is the fan is rotating. Now the here if you want to calculate the mass of the system, if you want to, this is our system here, this is our system here, this is our system. If you want to calculate the mass of the system, then there is a formula, PV equal to MRT. So from here M equal to PV by RT. So P is given, that is 100 kilopascal, you know. So here the pressure is given, that is 100 kilopascal. So from here 100 kilopascal, and V is given, that is 86.4, and R is 0.287, that is given in the question, and temperature 305 Kelvin. So here temperature basically 32 degrees Celsius is given. So here temperature is 32 degrees Celsius. This will be converted to if you add this degree Celsius to 273, then you can find 305 Kelvin. 305 Kelvin. So here that is why this is 3055. So from here you can find the mass of the system, that is 98.7 kg. 98.7 kg. Now you know the first law of thermodynamics, that is del Q, that is equal to du plus del W. So there is a insulated, so this is not correct, this is insulated, so that is why del Q is equal to 0, that is why del Q that is equal to 0. And here the fan is rotating, so that is why work into the system. So work into the system, that will be negative. So that will be negative. So that is why there is a negative sign. And the 60 watt means 60 joule per second, and the fan is rotating for 4 hours. So that is why here, suppose the fan is rotating here, the fan is rotating for 4 hours. Here you can see that the fan is rotating for 4 hours. That is here there is a 4 hours. So from here you can find what is the value of del W. There is a negative sign. Why? Because the work into the system. So that is why this is a negative sign. 60 into 4 into converted this 4 hours to second. So 4 into 60 into 60. This is second. So that is the work, amount of work that has to be goes on the system. Okay. So from this equation here from this equation you can say that del q that is equal to 0, del q that is equal to 0, that is equal to del u, we know the formula mcv t2 minus t1 minus del w, so plus del w, but we know the value del w, that is minus of 60 into 4 into 60 into 60. From here you can find the value, and the value will be 12 degrees Celsius. The value will be 12 degrees Celsius. So this is the answer. So here basically the temperature increases. So we can comment that the room is hotter. That means the temperature of the room is increases. So basically from here you can say that the value of T2 minus T1, the value of T2 minus T1 will be 12 degree Celsius. Okay. So okay. So this is the last lecture of energy introduction. So in this lecture we understand what is work and sign convention of work, and and closed system work analysis or non-flow process. If you go to the previous lecture you can find this topic, and there's work introduction in different process for non-flow or closed system. We see that how constant volume work is determined, and constant pressure work, constant pressure process, isothermal process and adiabatic process, what is the work done for adiabatic process and for polytropic process. Now we see that representation of various process and in PV diagram, and slope of isothermal and adiabatic process of PV diagram. So this is very important: isothermal process PV diagram and adiabatic process PV diagram. Now relation of different process, we understand that relation of realization of different process, that is constant volume process. How to understand this process: constant volume process, constant pressure process, isothermal process, adiabatic process. Okay, now we understand what is ideal gas and their formula, favorable condition, and cyclic process, and we understand that what is heat or heat transfer, understand that what is specific heat and sign convention of heat, and specific heat at constant pressure and specific heat at constant volume, what is specific heat at constant pressure and what is specific heat at constant volume. So okay, this is my handwritten notes. You can find the link is given on the description. You can find this, the link is given on the description. So here from there is a telegram link is there on the description, so you can join to get video lecture on time. You can subscribe my YouTube channel. Okay, thank you.